Let's see, what is atomic mass? Atomic mass will be one of the unique property of an element. Then an element is made up of any element is made up of its atoms, which are same. An element of oxygen or element of carbon, the element carbon, right? Its atom will be same. All the atoms of carbon atom are same. Or all the atoms of an oxygen atom are same. Why they are same? That means what is similar in them is that they have the all the atoms of an element. They have the same mass. That mass is called atomic mass. And what is mass? What mass is the amount of matter in in that in that substance or in that atom, which will be measured obviously measured in grams or kilograms. So now we're going to define we're going to understand what we mean by atomic mass or mass of an atom. Today we have a special technique called mass spectrometry by which we are able to individually measure the mass of an atom, which is extremely small. It's like 10 to the power minus 24 gram. This number is unimaginable. We cannot imagine how small this number is. Now, in order to understand the mass of an atom, we need to define a unit called AMU. Like how much is 1 kilogram? Now, if we have certain kind of like imagination, we have a feeling that how much will 1 kilogram weigh, how much a 50 kilogram weigh, how much 100 kg. I will not be able to lift an object weighing 100 kg, right? So I have a feeling how much is 1 kilogram. So now we're going to feel how much is 1 AMU, how much is 1 gram, or how much is 1 AMU. It's a kind of unit that we're going to use to measure the mass of an atom or atomic mass. So 1 AMU, which is a short form of atomic mass unit, is defined as 1 by 12 of a mass of a carbon atom. What we are trying to do is, see, at earlier times, hydrogen atom was taken as a standard atom. We are not, and like in earlier time, in 19th century, the scientists or people, chemists there were not able to measure the mass of an individual atom. What they did there at that time was that they were measuring the mass of an atom by comparing it with some other standard atom. So some atom was supposed to be taken as standard atom, and hydrogen atom was taken as a standard atom at that time. We were not able to calculate the absolute mass of an atom. We were just calculating relative masses or relative atomic mass. So this here also that we are going to calculate like a relative mass of an atom, not the exact one. Although the exact is 1.66, it will be around the value. It will be around 10 to the minus 24 gram. This will be the absolute mass of an atom. In 1961 it was agreed that carbon 12 will be taken as a standard atom, and compared to it, the mass of all other elements will be defined. And in order to do that, we are defining one atomic mass. One atomic mass is 1 by 12 the mass of a carbon 12 atom. Why carbon 12 again? Because here we see that the element carbon, according to the Dalton's atomic theory, which was given in around 1805, 1808, in the early 19th century. It says that all the atoms of an element are same, but later it came out that all the atoms of an element they also differ sometimes. They differ in their masses. For example, the carbon and those different kinds of atoms of an element are called isotopes. Carbon has three kind of isotopes: carbon 12, carbon 13, and carbon 14, which naturally exist in the nature. Although the percentage of these carbon atom differs. Say, for example, this carbon 12, it has 98% of carbon is carbon 12, and carbon 13 and carbon 14 are also there. So we have taken carbon 12, which has 90, whose abundance is 98% out of these three, comparing these three in the nature. So this is carbon 12 is one of the isotopes of carbon. So what is 1 AMU? It is 1 by 12 of the mass of a carbon-12 atom, right? And it turned out to be, but through mass spectrometry, it turned out to be 1.66056 into 10 to the power minus 24 gram. This is exactly what 1 AMU is. Otherwise, we can just remember how much is 1 AMU? It's 1 by 12 of the mass of a carbon-12 atom. 1 by 12 of the mass of a carbon-12 atom. But now we have replaced 1 AMU by U. We call it unified. We no longer say AMU, we say U. It's simpler, unified mass. And 1 AMU is exactly 1.66056 into 10 to the minus 24 gram. Or you can just say it is 1 by 12 of the mass of a carbon-12 atom. If you can imagine how the mass of a carbon-12 atom, it's 1 by 12 is 1 AMU. So how will you calculate the mass of a hydrogen atom? In terms of AMU is, we will, through mass spectrometry, we calculated that what the mass of one hydrogen atom is 1.6736 into 10 to the minus 24 gram. And when you divide it by this mass, 1A, this mass, you get the relative mass of the hydrogen atom in terms of atomic mass unit, which turns out to be 1.0078 AMU, or U, simply U. The mass of a hydrogen atom is 1.0078 AMU, or it is 1.0078 times 1 by 12 of the mass of carbon-12 atom. Whatever the mass of a carbon-12 atom is there, you divide it by 12, you get 1 AMU, and mass of that hydrogen atom is 1.0078 times that atomic mass unit. So when you say that the atomic mass of hydrogen is 1.0078 AMU, it is 1.0078 atomic mass unit, or unified mass, times 1.0078 times the 1 by 12 of the mass of the carbon-12 atom.